Okay, hello guys. Welcome to the fourth chapter, which we're going to be doing factors and polynomials. Again, I'll cover all the concepts, and I'll try to make it in half an hour again. It might be 5 minutes below, it might be 5 minutes above, but not too much. Okay. Again, if you have any questions, you can ask it in the comments, and those who are in the class, they can ask in the chat. Okay, or they can unmute. They have a better advantage because they are seeing this live. Okay, so factors and polynomials. This is I wouldn't say an easy chapter, but I wouldn't say it's a tough chapter either. Okay, and there's some slightly confusing things about the chapter and some things which I feel the concepts can be cleared a little bit more. Okay, so first thing, what's a polynomial? Okay, because a lot of this chapter is going to be about polynomials. So most of you guys will probably learn this chapter as polynomials, but you won't even know what a polynomial is. So like take 5 seconds, ask yourself, what's a polynomial? There are chances you'll have no idea. Okay, so here I'll tell you the definition of polynomial in basic words. Okay, if you check up in online, they will say, oh, it's an minus 1, blah 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 blah. Simply, polynomial is something you have x has a power. So suppose x power 4. Okay, that's literally a polynomial. So suppose you have 2x power 4 minus 3x power 3 plus 2x square plus x minus 3. This is a polynomial. What does it mean to be polynomial? Literally just x's, a chain of x's, and each of them have powers. Okay. If this is not there, if minus 3x cubed is not there, this is still a polynomial. Okay, and the highest power of the x is called polynomial degree. So this is 2x power 4, right? So this is a polynomial with degree 4. The only thing is these should be integers. Okay, so 2x power 3 over 2 is not going to work, and they should be positive. So 2x power negative 1 is not going to work. Can the power be 0? Yeah, sure. Like this negative 3 here is almost like you're saying negative 3x power 0, right? So, well, sure, if it suits you, but there should be a 2x power 4. Okay, these are all polynomials. No, it was important to know what polynomials are before we start the chapter, because half of you all probably will have no idea about it. Okay, now there's this thing called division of polynomials. And before I click on that, because I want you to understand the concepts with the essence, okay, with a feel. I don't want you to memorize anything. So let's understand basic division first. Okay, let's understand basic division first. So suppose I want to do 15 divided by 5. You'll be like, oh, Shamo, 3. Shamo, 3. You'll be like, I know. It's 3. Oh, what does it mean? What are you trying to do when you're doing 15 divided by 5? Okay, essentially, right? I know you guys will have many answers. You'll be like, oh, 15 divided by 5 is equal to x, so 15 equals to 5x. You're trying to find that. Yeah, all that's cool. Essentially, you're trying to find how many times, listen very closely. How many times can I minus 5 from 15 to get 0? I'll repeat. How many times can I minus 5 from 15 to get 0? So if I have 15, how many times can I minus 5? I can minus 5 3 times, because 15 minus 5 minus 5 minus 5 equals to 0. So I can minus 5 3 times to get 0. That's what division means. Okay. Now there are many methods of doing division. One is using mental maths. One is using your calculator. But when you're doing division of polynomials, you can't do either of those. So you need a method. And the method I prefer is called long division. But to teach long division using polynomials, I'll first teach you long division using simple numbers, which can be done with a calculator. Okay, so I have a problem which I want to do using this thing called long division. This is 6477 divided by 17. Of course, you can use a calculator, but I want to teach you how it works with long division for normal numbers. Then we can do it with polynomials. Okay, so how this is written in notations is essentially like this: 17, then they put this thing 6477. This is not a square root. Yeah, this is how the notation works. Now there are many methods of long division. There are many methods of division of polynomials. I find long division the most efficient one. That's why I'm teaching long division to you guys, and I strongly suggest you use long division. Okay. Your teachers will say, if your teachers say otherwise, or if you're really convinced that you want some other method that's easier, then go for that. Okay, if you're confused, then I would suggest you use long division. Okay, that's a safe one. So when you're doing 17 divided by 6477, you're trying to find how many times can I subtract 17 from 6477. Okay, the method is easy. You can first see just see the first two numbers. Okay, the first two numbers. There's two numbers here, there's two numbers here. What can I do? I know 17 times 3 is 51. Okay, how that works is you take 3 in the top. 17 times 3 is 51. So you can just minus 51 here. Essentially, you're not minusing 51, okay? When you're taking 3, because you're taking these numbers, you're essentially trying to minus 5,100, but the simplicity of the method is just 51, okay? So you're minusing 51. You get 7. 64 minus 51 is 7, okay? Now, here's the thing. This is 2-digit here. You want to have something with 2 digits here also. Like how it was 2 digits here, 17. You wanted 2 digits here, 64. Okay, so it worked out 3 minus 51, 7. Now you're given 7 and you have to do long division, but you have 17 here. So how it works is there's this 77 which is still not used. So one of the 7 comes down there. So it becomes 77. Can it be 777? Sure, but then you'll do it the same way. So let's keep that other 7 out. So it'll be 77. Now we'll do the same thing. Here you'll be thinking, I could use 4, I'll get minus 68. How am I deciding these numbers? I could have used 3 again, but then I'll get 51. You want to get as closer as you can to 77, okay? Because 17 times 4 is 68. 17 times 3 is 51. Why use 51 when I can use 68? Because 68 is closest. 68 is closest to it, okay? That's the method of long division. This is I learned this in year 3, guys. So it's a little bit hard to explain this, explain the method of long division because it's so glued to me as habit. Okay, so then this is 77 minus 68 will come 9. Again, this is 1 digit and this is 2 digits. So what you'll do is this 17 comes down here. Have I done any mistake? Let's see. Seems like there's a mistake. Okay, I spotted it. Okay, if this video is viral, then the comment section should have been filled. Okay. The mistake here is not in the concept, it's in my mental arithmetic. Now you'll be like, oh, Shamed, we trusted your mental maths. It didn't pay off today. Okay. If it's 3, I'll minus 51. I'll get 13 and not 7. Okay. Now you'll be like, okay, cool. This is 2 digits. This is 2 digits. But 13 is smaller than 17. Okay, by the way, apologies for the mistake. But yeah, 13 is smaller than 17. So you can't do it. So you have to borrow a 7 again. It becomes 137. Now, find the multiple of 17 closest to 137. You'll see if it's 8, 126 is the closest multiple. Then you can minus them. You will get 11. Again, 11 is smaller than 17. Borrow another one. And again, I feel I made a mistake. What am I doing today? See, this will be 136. No wonder. Oh, Shamed, you're not in the right mind today. Yes, maybe I'm not in the right mind. Okay, you guys maybe might want to share the videos more and ask more questions so that I'm more motivated for this. Okay, so then you get minus 17, 0. So that means 646,477 divided by 17 is equal to 381. That's how long division works. Sometimes you might get a remainder. Sometimes you might get a remainder, but in this case, you're not. Okay, so how does it work with polynomials? Okay, how does it work with polynomials? I have an example for you. Let me just get it. X cubed plus 3x squared minus 46x minus 48 divided. Again, this is not a square root. Square roots usually have this thing here. I'm not having that thing here. Divided by x plus 1. Again, now in this case, you can just look at the first number. But you'll need 2 numbers to go with it. Now, how does that work? You'll understand. I want the x cube. The main target is I want the x's to be the same. So I have x here, but I want x cubed. So I can multiply this with x squared. But the whole thing is multiplied. Yeah, I wanted x to become x cubed, but for that I have to multiply x squared. But even the plus 1 becomes multiplied by x squared. So it becomes x cubed plus x squared. When you minus these, 3x squared minus x squared becomes 2x squared. Okay, and then you can borrow this minus 46x. It's not borrowing, okay? It's literally just division. Okay, now you have x plus 1, you want 2x squared. Okay, like how from x you wanted x cubed, now from x you want 2x squared. So I can add 2x here. Okay, if you're having trouble with this, search up long division, and then you might have a better idea. I'm just trying to explain it very briefly to you because we have a time constraint also. Okay, and if you understand this long division properly, practicing polynomials will be really fun for you. Okay, trust me, it will be really fun for you. Then this will be minus 2x squared plus 2x. This is minus and this is minus. So this will become minus 48x, and then you can take, not borrow, this minus 48. Now you have x here, you want minus 48x, so you can multiply by negative 48 to get negative 48x minus 48. They add up to 0. So means x cubed plus 3x squared minus 46 minus 48x minus 46x minus 48 divided by x plus 1 is equal to this. This is your answer. Okay. Now your remainder is 0. Your remainder is not always 0. Okay, your remainder is 0. Your remainder is not always 0. Now, this was division at its core. That took a little bit longer than expected, but it's okay. Okay, now let's go to factors and polynomials. There's this thing called factor theorem. Okay, and factor theorem is really, really easy. So suppose this one, I'll just use the same result again. Okay, x cubed plus 3x squared minus 46x minus 48. When I divided it with x plus 1, so divide by x plus 1, what did it give me? It gave me x squared plus 2x minus 48. So what I'm going to do is I'm going to multiply both sides with x plus 1 because I can. And you'll know why, you'll know why, you'll know why. Everything has a reason. Now, tell me one thing, okay? Here's my question to you. These two things, if you use i's, these two things are multiplied. These things are multiplied, okay? Tell me, if either of this bracket is equal to 0, won't the whole thing become equal to 0? If either x plus 1 equals to 0, or either x squared plus 2x minus 48 equals to 0, won't the whole thing become equal to 0? And if this whole thing is equal to 0, these two are the same thing, so this becomes 0. So for example, if x plus 1 is equal to 0, this whole thing becomes 0. If x squared plus 2x minus 48 equals to 0, this whole thing becomes 0. And remember, all these are factors, okay? The definition of factor is that it doesn't give you a remainder. The definition of factor is that it doesn't give you a remainder. So for example, 2 is a factor of 4. 3 is not a factor of 4. Okay? Because 4 divided by 2 is 2 without a remainder. 4 divided by 3 is 3, then plus 1. You can't multiply them directly. This one you can. That's why they're called factors. Okay? Now, if either of them are 0, the whole thing becomes 0. So that means, suppose x plus 1, let's get the pen back. Suppose x plus 1. Suppose x equals to negative 1. This whole thing becomes 0. Anything multiplied by 0 is 0. And essentially, these two things are the same thing. So that means this whole thing on the right, this whole cubic polynomial becomes 0. What does that mean? That means if you have any factor, okay, and this works in every case. This works in every case, okay? If you want me to generalize it, I don't want to generalize it, but some students will feel that it needs to be generalized. Some will be happy with this example. So I'll give you both. Suppose you have a polynomial px, and I'm writing this as a function, and I'm writing p for polynomial, okay? And it has two factors, suppose, okay? Fx and gx. So if either fx or either gx is 0, then px becomes 0. By the way, I don't mean f0, okay, or g0. I mean fx equals to 0. They are different. F0 means I put 0 inside. Fx equals to 0 means x is equal to 0. So in this case, x plus 1. So I'm putting x equals to negative 1. That doesn't mean, so I want the factor to be equal to 0, not x to be equal to 0. I want the factor to be equal to 0. So if the factor equals to 0, the whole polynomial becomes equal to 0. And how do you make the factor equal to 0? Just equate it to 0. So in this case, x plus 1. So if x plus 1 is a factor, and you want to make it 0, Why you want to make it 0? We'll see. So x plus 1 equals to 0, x equals to -1. That means whenever I put x equals to -1, inside this, I should get 0. Okay, means whenever I put x equals to -1 inside this, I should get 0. In general, okay, because this was a x plus 1 case, if it's x plus b is a factor, then x equals to -b. Okay, if x plus b is a factor, then x equals to -b. So p negative b, p of -b will be equal to 0. Because when x equals to -b, this thing will be 0. If this thing is 0, the whole polynomial equals to 0. You understanding? Like how in this case, x plus 1 was equal to 0 when x equals to -1. So this was x plus 1. What if it's x plus b? Then p negative b will be equal to 0. What if it's ax plus b? You know, what if this was 2x plus 1 was a factor? Then for this to be equal to 0, x should be -1/2. So if x is -1/2, this thing becomes 0, then the whole thing becomes 0. So for ax plus b, it becomes -b/a. What's the point? What's the point you're trying to make? So suppose you have a polynomial px, okay, and the factor is ax minus b. Like in this case, it was x plus 1, right? Like in this case, it was x plus 1. So if ax minus b is a factor, so it'll be like, so basically it'll be px equals to ax minus b multiplied by something else, which I don't know. So I will say fx, suppose. Okay, because this is one of the factors, right? You'll have so many factors. So it's ax minus b multiplied by something else. P of b over a will be equal to 0. Now, what the hell does this mean? See, very simple, okay? If ax minus b equals to 0, ax minus b equals to 0, px will be equal to 0. When will ax minus b equal to 0? When x equals to b over a, ax minus b equals to 0, x equals to b over a. None. So then p b over a equals to 0. The other way around also works. If p b over a equals to 0, that means ax minus b is a factor. So if p -3 equals to 0, that means x plus 3 is a factor. If p -2/3 equals to 0, that means what will be a factor? What will be a factor? What will be a factor? 2x minus 3, 3x plus 2. What do you think? What do you think? 3x plus 2 will be a factor. The point is, when this is equal to 0, you get -2/3. When this is equal to 0, you get -3. That's the logic behind it. That's the logic behind it. When one of them is 0, the whole thing is 0. So when is one of them 0? Ax minus b becomes b over a. Okay, and they'll ask you so many questions on this. Now, what's the particular use of this? In your syllabus, there's one thing called factorizing cubics. Factorizing cubics. Okay, so let's take the same example. Let's take the same example. We had x cubed plus 3x squared minus 46x minus 48. Last time we knew that if you divide it by x plus 1, last time the question asked, divide by x plus 1. What if the question just says express it in terms of, what if the question says that express it in this manner without telling us about the x plus 1? What do? Simple. We find a root. We find a value for which this thing equals to 0. For example, if x equals to b is any number, this becomes 0. That means x minus b is a factor. Okay, so in this case, if you will notice, let's see -1. Okay, this will become -1 cube plus 3 times -1 square minus 46 times -1 minus 48. This will be -1 plus 3 minus plus 46 minus 48. This will be 0. So if x equals to -1 is giving you 0, that means x plus 1 is a factor. X plus 1 is a factor. So if x plus 1 is a factor, that means now you can do your long division, because we already found x plus 1 is a factor. Now, Shaman, how will you know these values? Okay. See, usually they will not ask you this type of question in the exam. But if they ask you, you need to trial and error these values. You need to trial and error these values. Okay. Yeah, that's pretty much it for the factor theorem. Now, for the remainder theorem, I want to just expand on our idea of long division a little bit. Okay. By the way, factor theorem, I hope everything was clear. I feel I've done a good job explaining it. Just rewind the video or ask any question if you feel that it was not 100% clear. Okay. Rewind the video, watch it in 1x speed. I know some of you might be watching in 1.5x, 2x because I'm speaking slow. watch it in a decent speed, not too slow also, because 1x might be a bit slow. So 1.25x maybe, but try to understand what I said, because it'll be really fun to understand it and to learn it once you actually know what's going on. Okay. Now, I want to go to remainder theorem. This is the last thing for this chapter, and then you can play whatever game you want, play do watch whatever movie you want. Okay, stick with me, guys. Okay, it's ironic how I am forcing you to study for yourself. So by that I mean you should be focusing on yourself. Okay, I am pushing you, so come on, do it for yourself. For remainder theorem, I just want to expand on one particular point. Okay, I just want to expand on one particular point. Suppose we have 216 divided by what was the number I wanted to do? 48. I have it all written down. Okay, so I have to look here a little bit. I need to be prepared for you guys, right? So how will you do this? So 21, you'll take 2 register 40, 21. But 21 is not working. 21 is lesser than 48. So take the whole thing, 216. You'll notice 4 is the number. 192. You're getting a remainder of 24. You're getting a remainder of 24. So understand. Okay, Shamit, what is that to understand? See, earlier when we did, what numbers did we choose? 6, 4, 7, 7 divided by 17. We got over here 381, and the remainder we did blah 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 blah. The remainder was 0. That means 17 times 381 was equal to 6,477. That's what it meant. Okay, and there's no remainder anymore. There's no remainder. So 17 times 381 was equal to 6,477. Now in this case, 48 plus 4 is not equal to 216 because there's a remainder. So 216 is equal to 48 times 4 plus the remainder plus 24 plus 24. Okay, try to get a feel of it. Remainder means what? After you divide, what's remaining? Remainder. What's remaining? Right? So for example, 3 divided by 2. 3 divided by 2. Okay, guys, common sense. 3 divided by 2. Well, we know it's 1.5. We know it's 1.5. Okay, but if you have to write it, if you have to first see how many whole times. Okay, so don't tell me decimal values and stuff. Okay, what's the maximum amount of whole numbers? So 1.5 doesn't count. What's the maximum amount of whole numbers I can minus 2 from 3 to get 0? I'll say that again. What's the maximum amount of whole numbers I can subtract 2 from 3 to get 0? It'll only be 1, because I can subtract 2 from 3, I'll get 1. I can't subtract it 2 times, I'll get -1 already. Okay, or let's do 5 divided by 2. How many whole numbers? Okay, I want whole numbers. I want to subtract 2 from 5. How many times can I do that without getting 0? Whole numbers. The maximum amount of time. So you'll be like, okay, 2 times. You can do that 2 times, but you won't get equal to 0. If you subtract 2 times, you'll get 5 minus 2, which is 1, not 0. So what's the remainder? I couldn't say 3 because that will already be -1. So what's the remainder? So in this case, 24 is the remainder. 24 is the remainder. Okay, so if you want to do 48, if you want to do 216 divided by 48, it's in this form. How about we divide 48 on both sides? This becomes 4 plus 24 over 48. So it becomes 4 plus 1 over 2. So now it becomes 4.5. This is how you can say it. Having fun? If you're not having fun, rewind. Okay, I hope you understood that. Now, why is that important? Now let's expand this to factors and polynomials again. Okay. Suppose I have a cubic and I have the cubic plan for you guys. 7x cubed plus 6x squared. I'm going to be a little bit quick, okay, because we're approaching the half an hour limit, but I'll make sure to balance quantity and quality like I always do. Okay, leave that to me. Trust me. Okay. Divided by x plus 3. Okay. So if you guys have time, right? So you pause, you try solving this. Okay. But very quickly, if you wanna, you'll get a remainder in this. Okay, you will get a remainder. So if you want to do long division, you get 7x squared. Long division is in my opinion, the best way. Okay. 7x cubed plus 21x squared This becomes negative 15x squared. Minus 40x, you bring it down. So you'll get minus 15x. Minus 15x squared minus 45x. You'll get minus positive. So 5x plus 17. So then plus 5 will become minus 5x plus 15. So it'll give you 2. It'll give you 2. Now, using the same logic, what does this mean? Using the same logic. Using the same logic, it means that 7x cubed plus 6x squared minus 40x plus 1 is equal to, let's see, 48 times 4 plus 24. Means I can minus x plus 3. This is a little bit hard in terms of x's, not the girlfriend boyfriend one, the mathematical x. Means I can subtract x plus 3 from this these many times. Okay, you want, I can do it this way for you. Let's call this 1, let's call this 2, let's call this 3. I can do this is going to be funny. I can do 2 minus 1 3 times as a whole number. Like how? Here, you could do 216. You could subtract 48 4 times as a whole number. The 5th time, you're already going into negative. Okay? What will you be left with? You'll be left with 24. Like how 5 divided by 2? 5 minus 2 minus 2, you were left with 1. In this case, 216 4 times. So minus 48, minus 48, minus 48, minus 48. You're still left with 24. You minus another 48, you're already in the negative. So 24 is your remainder. So in this case, this is your remainder. So if we wrote it like this, 216 is equal to 48 times 4 plus 24, which by now I hope it's common sense to you. We can write this as 7x squared minus 15x plus 5 multiplied by x plus 3 plus 2 plus 2. We can write it like this. Okay, I hope you guys understood that. Let me just copy this. Let me just copy this line and move it to the next gen, and then we'll explain this last concept so that we can call it a day. We had this concept, okay, and I hope you understood this really nicely. Now I have a question. Now, what if one of this? Now you can't call this factors anymore. Okay, now x plus c is not a factor. It's not a factor, but it's still a nice. But it's still a algebraic expression. It's still x plus 3. Okay, it's not nothing. It's not a factor though, because it's giving you a remainder. Okay, factors don't give you a remainder. Okay, so now you have x plus 3 and 7x squared minus 15x plus 5. Now these two, this is not an equation. Okay, this is not an equation. These two are equal to another, equivalent, like they're the same thing. I'm not trying to show that this is an equation. I'm trying to tell you that these are the same thing. I can write this as this. They are the same thing, okay? Like how you can write 1 as 2 minus 1, right? If I say 1 equals to 2 minus 1, that's not an equation. That's saying that, hey, they are two different ways of writing the same thing. So these are the same thing, okay? They are not an equation. Like 2x equals to 4, there's only one value of x for which that happens, right? But 2 minus 1 is equal to 1 is always true. This is always true. This is not this is the same thing basically. Okay? Why am I telling you this? Now, suppose one of these things, one of these ones, let me write it in red here. If one of the things in red is equal to 0, okay, so either x plus 3 or 7x squared minus 15x plus 5. Suppose x plus 3 is equal to 0. The whole red thing becomes 0. If x plus 3 is equal to 0, the whole red thing becomes 0. You're only left with 2. And remember, this thing is literally the same thing as this thing. That means if either this is 0 or this is 0, you are left with 2. That means this becomes 2. Okay? I hope that was clear. Because if x plus 3 is equal to 0, suppose x equals to negative 3, okay? This becomes 0. So if this becomes 0, the whole thing becomes 0. This whole red thing becomes 0. Then you're left with plus 2. So plus 2 is what you get. And this thing, this left-hand side is the same as the right-hand side. They're not an equation. Yeah? They're the same thing, as I said. There's one way of expressing another way. So you get plus 2. So that means when x equals to negative 3, this thing becomes plus 2. Okay, I hope that was clear. I hope that was clear. Okay, I hope that was clear. Now, what does that mean? What does that mean? So if any number is divided by a factor and it gives you a remainder. So now it's divided by x plus 3. It's divided by x plus 3 and it gives you a remainder of 2. What does that mean? What does that mean? So if it's x plus 3, I want this whole thing to be, I want the red underlined part to become equal to 0. So I can make x equal to negative 3 and then I'm getting a remainder of 2. So that means if this was px, so suppose px equals to 7x cubed plus 6x squared minus 40x plus 1. That means p of negative 3 is equal to 2. Okay. So in a general case, if you have a polynomial px is equal to fx times gx, these are just two functions. Okay, I'll make the p look better. Plus a remainder. So let's call the remainder rx. Okay. Shamit, why is the remainder a function? Sometimes the remainder can be a function also. But in your case, usually it's only a number, like how remainder is 2, right? Sometimes remainder can be x plus 2. But okay, I'll just call it rx. Okay. You never know what they might ask, but usually for your case, the remainder is just a number. Now, if either fx equals to 0 or if gx equals to 0, that means that this will become equal to this. Okay. Now, what are fx and gx? Fx and gx are written in these forms, in simplified forms. In simplified forms, right? So usually fx, usually fx will be in the form ax plus b. Gx will also be in the form ax plus b. Let's say bx plus c. No, cx plus d. Okay, because I already use ax plus b. Let's use cx plus d. And if there is a cubic, if it's a cubic, there might be fx, gh, and hx. So hx is ex plus f. Okay, but sometimes gx can be a quadratic if it can't be factorized. You generally try to simplify it as much as you can into ax plus b terms, into polynomial with power 1, with degree 1. But sometimes you can't factorize quadratics. Why can't you factorize quadratics? Hey, watch my video on quadratics. If the discriminant is negative, you can't factorize quadratics in real roots. Okay. So yeah, if either fx equals to 0 or if either gx equals to 0, then the polynomial will be equal to the remainder. So that means if fx, so let's say that means that p, let's use a different color, p of negative b over a will be equal to r of negative b over a. But again, as I'm saying, r of negative b over a, it will usually be a number. Like r of negative b over a, in this case, 2 is my r x, right? So whatever value I put, this is going to be equal to 2 only. So it's r negative b over a if the remainder is a function. So in this case, when it's plus 2, then rx is not really a function, but it's the remainder. Okay, so it's almost like rx equals to 2. So no matter what value of x you put, you'll get 2. So usually, but I don't want to be 100% sure, right? That's what I'm saying. Usually this is just going to be a fixed value. 99.99999% of the cases, this is going to be a fixed value. So they will say, so like the remainder might be 2, the remainder might be 3. If the remainder is something like x plus 3, then this can get helpful. But 99.99% of the time, it's a fixed value. They'll tell you 2, 3, or sometimes they might ask you to find it. Okay. And g of, this is cx plus d, by the way. So g of negative d over c will be equal to r of negative d over c. Again, this will probably be a fixed value. 99.9% cases, like how just now we had 2. Okay. So that was all for factor theorem and remainder theorem. Just one summary which I wanted to show you guys. I've taken this from my textbook. You might use a different textbook. That's not a problem. Then this is the summary for you. If they're going the forward way, I like to go the backward way. As I've taught you, if x minus c is a factor, then pc equal to 0. But you need to know the other way around also. You need to know the other way around also. If 1 plus 1 equals to 2, 2 is also equal to 1 plus 1. So what will which, how do you know which direction the question might ask you? They might go from PC to X minus C, or from X minus C to PC. So know both. And now it's logic, so you should understand both. If it's in the AX minus B form, then it will be PB over A, because AX minus B equal to 0 will be X equals to B over A, right? And same thing here, but then there will be a remainder. See, they're also using PC. Oh, no. For them, remainders, see, the remainder is usually a fixed value. Like how they're doing PB over A is equal to remainder, or P negative. Why is this negative B over A and this is positive B over A? They are using AX minus B. I'm using AX plus B. Okay, that's the reason. Trust me, I don't make that many mistakes. I know what I'm doing. Okay, except for the first 5 minutes of this. Yeah, that's a summary for you. And again, if this is confusing you, then don't worry, because I don't want to be 100% sure, but 99.999% of the cases, your remainder will be a fixed value. Okay, so that's it, guys. Sorry for going slightly over the time limit. It's become 40 minutes instead of 30 minutes, but this was a very fun. It was very fun to teach this chapter, and I hope it was equally fun to learn it, because many times you guys are not taught this with the concept. You guys are just taught to memorize this summary. And if I just told you that, I could have done it in 5 minutes, but well, I just have a. I like to praise myself a little bit. Okay, I feel I deserve it for the content which I'm giving, all the content for free, and that too on YouTube for every chapter, in one shot, right? And again, I just want to make sure these are just the concepts. Okay, we haven't done many questions on them. The questions we'll do in past year papers. For videos of those also I will upload. Okay, for videos of those also I'll upload. But the only thing which you would like to keep in note is we can't do as many past papers here. We can't do, and I can only cover the main concepts. The main concepts. Like in this chapter, I think I covered all the concepts, but in some cases, there are sometimes I can't cover all the concepts because of the time limit. Like in functions, if you saw the video, I couldn't cover all the concepts. So all those concepts I discuss in the tuitions which I give. Okay, and those ones you can check the description, the pin comment and stuff. Okay, so yeah, but hopefully these videos are helpful for you. If you need extra help, then you can check the pin comment. I think I deserve a bit of self-promotion for what I've given you. Okay, but yeah, anyways, that's it. Okay, keep enjoying this chapter, keep enjoying Add Maths, keep enjoying studying. I hope you are alive, and I hope I'm increasing your chances of improving. So thank you for watching here, and yeah, see you in the next video. Until then, take care, bye bye, stay safe, peace.